Hi, I'm El Queso Grande. You've seen me in such fine quality epic chemistry videos as Density, It's So Dense, and Are Things Really More Dense Than Water and Still Float? Today we're looking at the first AP Chemistry lab dealing with density. Now I'm going to make this a little bit different in that you're not having these nice little cubes that you can easily calculate the volume and all that. No, we're going to be doing it a little bit differently. We're going to use a different method. But first off, what's density? Think of density as how much material is packed into a certain amount of something. How much material is packed into a volume. Okay? So there are things that are not very dense. They're very pretty light. Okay? And there are things that are fairly dense, like lead, for example. So, if we look at the formula for density, all that density is, ladies and gentlemen, is simply the density is equal to the mass over the volume. That's the idea. So, with that, we can easily find the mass of an object because we can use our electronic balances. The volume is going to be a little bit more tricky. There are some math formulas we could use, but what happens when you have an object that doesn't really fit into a mathematical equation like this nail, for example? Say, oh, but there's a cylinder. We could approximate it. You could, but let's face it. You see this little pyramid, this non-Illuminati affiliated pyramid? That's going to be a little bit more difficult to calculate. So there is a way to find that out. First, we need to look at the gear that we're going to need for this. For the safety gear, we're going to need the apron, okay, in case you get water splashed all over your fancy clothes. And the other thing you're going to need are the goggles to protect the eyes, because you are going to be working with glass. And glass can shatter and, well, you know the rest. Now, we're going to have a cylinder, and I'm using a 100 milliliter graduated cylinder today. We're going to need some kind of a beaker with water in it. And then we have this, the 1 milliliter syringe. Okay, and it is graduated. And we're going to show you how we're going to go and figure out the volume. But first, let's go ahead and let's try to calculate the density of this nail. So first off, we're going to go ahead and we're going to find what's the mass. So we're going to go over, and you are going to have your electronic balance, and notice it's set at 0. Now if it's not at 0, remember you can press the re-zero button and it'll set it. So we put that in. Okay, 9.95 grams. Fantastic. So then we can go on back, and we have our mass here, 9.95 grams. Fantastic. Now, our next trick. How much water are you going to put in your cylinder? Well, it depends. Depends on the size of your object. If your object's tiny like this, you're not going to need, 50 milliliters of water. On the other hand, for an object like this, that's long, when we drop that in, we want to make sure that it can go totally under the water, which is submerging it. How are we going to figure out the volume? Well, the idea is this takes up a certain amount of space, volume if you will. Now if we put it in here, the idea is it's going to push up the water that is equal to the volume of our object, in this case our nail. Now I have this already set at 100 milliliters even. It's already done because we didn't want to measure with the thing. So we're going to go ahead, and in this case with the nail, I'm going to drop it head first. Now it's really important that you don't have any air bubbles here in the cylinder, because that will throw off your volume results. So now we can go ahead and take a look. It was at 100, and let's see, not 100, I'm sorry, 50, 51, 52. It's in between 52 and 53. How in the world are we going to figure that out? That's where this comes in. This is a 1 milliliter graduated cylinder. In other words, it's graduated in tenths of a milliliter. This is very useful for us. So what we're going to do, we're going to take this, we're going to put it in here, and we are going to draw out the water, and we want to go all the way to the 1 milliliter mark. Okay.
Now that would be kind of important that the top part of your rubber thing here, the rubber stopper, is going to be at the 1 milliliter mark. That would be important. Now in this case here, ladies and gentlemen, I got it just at it, okay? And you want to make sure that you don't have any air bubbles. Now I happen to have no air bubbles in here. That would be kind of important. If you have air bubbles, go back in, squirt it out, and then pull up again gently. Take in more water. You don't want air bubbles in here because we need to have a precise and accurate measurement. Okay, now that you've got this, it's got 1 milliliter of water. We know that this is in between 52 and 53 milliliters. What we want to do is add enough water to bring the level of the water here to the next whole milliliter. In this case, from 52 to 53. So here we go. Notice I'm using drops on this, and I'm going to have to pay attention to my... Now remember, when you are reading your cylinder, remember your meniscus. Remember how you take your measurement for this. Okay, guess what? I've reached the 53 milliliter mark. I'm going to come around and I'll show you. If you take a close look here, and you'll notice, all right, this is how much water that we used up. But how do we know how much volume, extra volume, that it took? It's this reading right here. This is what's left of that fraction of a milliliter, that part of a milliliter that we have. So in this case, we can look and say, all righty, that is... As I take a close look at that, that is about 0.75. So we measured from 50 milliliters to 52 milliliters, okay? So we have our 50 milliliters, that's what we had for our graduated cylinder at the start. We kicked it up 2 milliliters when we dropped it in, but it was in between 2 and 3, right? This is our fraction of between the 2 and 3. This is what's taking up the space in our nail, that our nail takes up. And in this case, it's 0.75 milliliters. So with that, ladies and gentlemen, we can figure out that the total volume that we have now in our cylinder, I shouldn't say this, let me rephrase this. This is what we have. What you started out with in the cylinder, when we dropped the nail, it went between, it had 2 whole milliliters, and then the extra milliliter. We should be adding this. What we have here, ladies and gentlemen, is the entire volume of our nail in here. You'd say, wait, I don't get it. Where did you get the 2 from? Well, remember, if the original volume was 50 milliliters, we dropped in, that was our initial, okay? We dropped in the nail, and we said it was 52 milliliters. That was the final before syringe. Whoops. So 52 milliliters is the final before the syringe. That's our Christmas frog I got from last Christmas at the, that was my white elephant from the last Christmas party.
So cute.
Okay. Anyways, yes, I can't take credit for this time because my daughter Elizabeth is being the camera person today, and that makes it a little bit easier for me to move around. You can give her props.
Yay!
Okay. So 52 milliliters final before the syringe. We know it was between 52 and 53 milliliters. We found that it was 0.75. So that means it jumped 2 milliliters plus the 0.75 milliliters, and our total volume was 2.75 milliliters. That's how much volume that this nail took. Now, I also want to point out, if there's any air bubbles on the nail, you may want to get rid of those as well, because that can throw off your results as well. So, after that, all you need to do is just take 9.95 grams, which we weighed, and divide it by 2.75 milliliters of volume, and that's going to give us the density of this nail. Now the chances are this is an alloy, combination of 2 or more metals, okay? But still, you're going to be dealing with several different objects in here. Some of them we're already going to know. We have an aluminum nail, we have a lead weight. Notice that they're not exactly shaped regularly. Okay, we also have brass as well, and I think that would be it for our lab. Anyways, I hope that this will help you guys out, and you should be able to go in with confidence into that first AP Chem lab. Okay, this is El Gran Queso signing off.